Hello everyone, hope you all are doing well. So today we will start our new lecture. Before starting lecture, do subscribe my channel, like, share and don't forget to press the bell icon for more updates. Let's start with our new topic, that is rules for assigning oxidation number. Yesterday our topic was redox reaction and oxidation number, and today we will learn the rules for assigning the oxidation number. There are 7 or 8, I think 8 rules. First rule is saying that oxidation number of all elements in free state, uncombined state, is taken as 0. What does mean by free state or uncombined state? Free state means the element that is not with an other element and it's not making any compound. There are just elements like potassium, chlorine, hydrogen, oxygen, like these, and etc. Like calcium, potassium, this is a single element, so it will be in free state, means it's not combined with anyone, so it's uncombined state. We will take its oxidation number as 0. Chlorine 0, hydrogen 0, oxygen 0. Till they are not making compound with another, we will consider it as 0. This is our first point. Let's move to second point. Second point says that oxidation number of monoatomic is same as charge appears on it. Yesterday I make a one chart over here. In that chart I write all the monoatomic I write all the charges over there. So here are the example, like it will be the same as a charge of it. The oxidation number of that element is also same like that. Let's taking an example of sulfur. Sulfur Na. Sulfur in sulfur we are having Na. For example, we are having sulfur. Sulfur is Na. We are having sulfur. In sulfur, we are having Na. And like we are having calcium, Ca. In sulfur, we know that charge on sulfur is +1. So the oxidation number of sulfur is +1. We know the charge of calcium, it's +2. So we know that the oxidation number of calcium is +2. In third point, it says that sum of oxidation number of all element in a neutral compound is 0. What is mean by it? That sum of oxidation number of all element in a neutral compound is 0. Let's take an example. Like we are having H2SO4. These are single elements that are making a neutral compound, and that is equal to 0. How it's equal to 0? Let's suppose I have H2SO4. I know that in H2SO4 the valency of oxygen is -2. Okay, so it's 4 2s are what? 4 2s are 8. So it will be -8. 4 multiplied by -2, -8. And after that I know that hydrogen having 1 oxidation number, so 2 ones are 2, so we will write 2 here, and remaining we are having 6. It means sulfur having 6 oxidation number. So 6 and 2, we add these both, so it will be a +8. When we are adding, we are using H2S8 and O4 8. 8 minus 8, our answer will be 0. So it means it's a neutral compound, that is equal to what? That is equal to 0. Okay. Now let's move to towards the fourth point. Fourth point says that oxidation number of oxygen in most compound is -2. Like now I did H2SO4. I said that its valency is -2. So the oxidation number of oxygen in more compounds are -2. But it's saying that however in peroxides, oxides compound. Means per oxide, per means 1, so it means in per oxide it is -1. Okay, means the oxidation number is -1. That thing we have to remember. In superoxide it's -1 upon 2, means per oxide, super oxide. And in oxyfluoride, now here we are not using oxide as we were saying per oxide, super oxide. Here we are using oxyfluoride, so it's +2. Why oxyfluoride is +2? Because the fluorine have, because high electronegativity in fluorine. Fluorine is the, in all the elements fluorine is the high electronegative. That's why there is the more valence, more oxidation number of fluorine. Let's you take an example like -2 example I have taken here. Now -1 example. Likewise here we are having Na2O2. As we know that it's a per oxide, so here we will use what, -1. So here we have used in -1, 2 ones are 2, and sulfur having 1. Okay, it's 2 ones are 2. When 2 minus 2, it's remain 0. Okay, it remain same. So this is the method to do this. Like we know, we have to remember that per oxide is equal to -1. Now let's talk about superoxide. In superoxide the same thing happens. Like in superoxide, as I told you, -1 upon 2. Okay, so we are having KO2. This is a superoxide, so here we will use minus, just wait, here we will use -1 upon 2. Now we will multiply it with that, so -1 upon 2 multiply by 2. So 2 cancel with 2, just -1 is remaining. Okay, and here we know that potassium oxidation number is +1. When 1 -1, they both will cancel. And here we also prove that the -1 upon 2 is the oxidation number of superoxides. Now let's talk about oxyfluoride. In oxyfluoride we are having more electronegativity in fluoride, so we are taking OF2. So it means more electronegativity in fluoride, so we'll put minus over here. We put what? We put minus over here. And oxygen will be positive because it's a less electronegative. And we know that the oxyfluoride is +2, means oxidation is +2, so we'll put 2 over here, because plus when multiply with minus it's -2. And we know that valency of oxygen is 2. When 2, wait, here one more thing, that we are having minus oxyfluoride is +2 because high electronegativity in F2 and there is low electronegativity in oxygen. So here we are having -2, here we are having +2. +2 cancel with -2 and it's cancel out. Our answer will be 0. Okay, that's why there is a high electronegativity in oxyfluoride. Let's move to another point. That fifth point is saying that oxidation of hydrogen, means oxidation of hydrogen in covalent compounds is assigned as +1. Means oxidation of hydrogen fluoride in covalent compound is assigned as positive, what? Assigned as +1. Acha, one more thing. We did here OF2. Okay, now what will happen, that it's negative, it's positive, so we will cross it. So O2 will go there, and fluorine having its own 2, so 2 minus with 2, here will be no 2 here, so it's equal to 0. Now after that it says that the oxidation of hydrogen in covalent bond, oxidation of hydrogen in covalent compounds is assigned as +1. In metal hydrides, its oxidation is -1. Its number is taken as -1. What it means? Like it says that when we are having hydrogen with non-metal. Okay, then we are having what? We are having hydrogen, we are having positive, no non-metal negative. But when we are having hydrogen with metal, so it means hydrogen negative and metal positive. Here are the some of the examples of that. Like, just wait. Here are the some of the example, like NaH, like Na is sulfur and H. As I told you that we are having metal, so we will take it positive and hydrogen will be negative. But if we are talking about non-metal, carbon and hydrogen, so hydrogen will be positive, carbon will be negative, because carbon is non-metal, hydrogen will be positive automatically. So this is the method, and in this method, as it says that in metal oxide the number is taken as -1 of hydrogen, so it's -1, we will take as -1. So in metal oxide we will use as -1 over here, and here sulfur is +1. It cancel with it, we are having nothing is remaining. In carbon it's +1, we are taking +1 here, and carbon having oxidation number 1, so minus will cancel with +1, we are having nothing remains. So here now move to the 6 point. 6 point says that oxidation number of 1A group and second group are assigned as +1 and +2. This we have done in our last lecture, where we have made table. Like in first A group we are having all the elements with +1 oxidation number, and in second group we are having with +2 oxidation number. To move on to 7 point, it says that the oxidation number of fluorine in all compound is always taken as -1. As I told you previously, why we are taking it as -1, because there is a more electronegativity in fluorine in all the elements. And it says that because it have high electronegativity than all elements, will take -1 if in bonding the compound have more electronegativity. Like, it's not a speciality of fluorine, is actually the speciality of fluorine that we are taking -1, because in all the elements it is higher electronegative. But if we are having oxygen, okay, so we will take oxygen as -1, because oxygen have more electronegativity than others, but less electronegativity than fluorine. So then when we have oxygen and fluorine, so we'll take fluorine as a electronegative, it will minus, and oxygen will be positive automatically. On 8 point, it says that in polyatomic ions, it is very simple point. They're just telling us that, like in more than one, we can say, or more than two, in polyatomic ions, the sum of oxidation number means more than one, or you can say more than three we are having. So if we will do the sum of their oxidation number of all the atoms present in them, like here are the atoms that present in them, we add all the oxidation number, it will equal to net ionic charge on the atom. Like, what will be the net ionic charge on the atom? It will equal to oxidation number, like sum of all the oxidation number is equal to the net ionic charge that is present on them. 8 point simply says that. Now here I am taking one conception that yesterday we did one method to find where we were finding their we can say oxidation number, that how to find oxidation number of tri atomic. So I am doing that mathematically. It is quite easy mathematically too. Okay, in mathematically we are having aluminium Al, and here we are having nitrogen, here is oxygen, here is 3, and here is 3 outer. Okay, let me check that as I have written it correct or wrong, because here are some of the more statements. El and 3 or 3. Okay, it's correct. So now what we'll do, as we know that aluminium having the oxidation number +3. Okay, so we'll write +3 over here. We know that here outside of the bracket here is 3, it's on these both, So first of all we will take this bracket with nitrogen, so plus 3n, okay, and plus we will multiply 3 3s are 9, okay. We know the oxidation number of O, so we'll write the oxidation number of oxygen, that is -2, okay. After that 3 plus 3 nitrogen plus 9 2s are 18, so here will come -18, so we'll put -18 over here. Now when we will do 3 minus 18, so here will be remain 3 nitrogen minus 15, and after that 3 nitrogen here is equal to its -15. When it's moved there, it's +15, okay, and nitrogen is equal to 15 divided by 3. Firstly it was multiplying, now it moves there, so it will divide. So 3 1s are 3, 3 5s are 15, so nitrogen oxidation number is 5. This is one more method to find the oxidation number of not giving element. So that's all that we have learned today, and it was quite easy. We just have to remember the rules for assigning oxidation number. Thank you so much.